All right, so today what I'm going to ask you guys to do is take some notes from this video on page 11 in your packet. And so on page 11, there's a note guide that goes along with trophic levels and ecological pyramids. The essential question I want you to think about again is, how can energy flow throughout the ecosystems? You'll see this picture here shows you a pyramid, and we're going to be talking about these pyramids quite a bit. Each section of this pyramid is considered to be something that is called a trophic level. And so when you look at pyramids, there's going to be different variations of them because there's three different types of ecological pyramids ecologists have come up with. And each step in a food chain or food web is referred to as a trophic level. So here's a trophic level. Here's a trophic level, here's a trophic level, and here's the fourth and final one near the top. You're always going to find those primary producers we learned about in our web quest down here at the bottom. They're going to make their own food. So here's where you would find the autotrophs, and then the primary consumers would then eat these primary producers. And so various consumers are going to be at these different levels. So this bottom level here, or quite honestly over here to the right, would be considered the primary producers. This next level would be the primary consumers, because they're going to consume or eat the producers down below. Then this purple part would be the secondary consumer, and up top would be the tertiary consumer. And potentially we could even have the next level, which would be the quaternary consumers. And so ecologists have come up with different types of ecological pyramids that show the relative amount of energy or matter that's found within each trophic level. And so over the years, we've developed three different types of ecological pyramids: a pyramid of energy, a pyramid of biomass, and the pyramid of numbers. And so in your note guide, we want you to get a little bit of information down about each one of these, and then we're going to ask you to do a lab activity. And so the first pyramid is the pyramid of energy. One of the things that we've talked about since honestly the first week of school is that organisms need energy in order to live and survive. And so they use their energy up going through many different processes, like simply breathing or moving, or each day that goes by, we grow a little bit, and over the years, eventually you're going to create offspring of your own and reproduce. All of that takes energy. Here's the thing. Most of the remaining energy is released into the environment as heat. So another way to say that would be any of the energy that you don't use to help you breathe or move or grow, the rest of that energy, or at least part of it, is released in the form of heat to the environment. It's kind of what we call a byproduct of that. And so on average, about 10% of the energy that's available within one trophic level is going to be transferred to the next. So think about all of the energy that's found down here with these primary consumers. They're making tons of food for consumers to eat. The problem is, in order for themselves to make their own food and to grow, it requires energy, right? And so only 10% of the energy here is going to be transferred up above, which also means then of the 10% that is here, only 10% is going to go to the next trophic level and to the next trophic level, because all of that energy, if we go back a slide, is used in all of these different processes. Some of the other energy gets released to the environment in the form of heat, so only 10% gets passed on from one trophic level to the next. And so when we start thinking about that, it really makes us start wondering, why do organisms at the top of a food chain, or maybe even at a food web, have to eat so much? Well, here's why. Suppose 30,000 kilocalories of energy is in corn. How much is available to the rat and or to the eagle? Well, if you look at this food web over here, the rat is found here to the left, and the eagle is found way up here towards the top on the right. Well, if there's 30,000 kilocalories of energy in corn, so here's our primary producer down here, how much of that energy that is contained within that corn is going to be given to the rat or to the eagle? Well, if we follow the food chain of corn to grasshopper to get to our rat first, if there's 30,000 kilocalories available, when you look at how much energy the grasshopper is going to obtain from when it eats the corn, the grasshopper is only going to get 10% of that, or 3,000 kilocalories. And again, if we look at how much energy then is available in the grasshopper and how much energy it can pass on to the rat, it's only going to pass on about 10% of that, so the rat's only going to get 300 kilocalories. So you might think, oh, it's great to be at the top of a food chain, or in this case, a top of a food web, but you have to eat so much more when you're at the top, because the higher up you go, the less calories there are available to you when you eat that food beneath you. And so if we look at this in the same way of how much energy the eagle is going to get, well, in order to get the energy from the corn all the way up to the eagle, the corn is eaten by the grasshopper is eaten by the frog, and then the frog gets eaten by the eagle. So if we do this, maybe some of you have already figured this out, going from corn to grasshopper, reduce it by 10%, which means we really just lop off a 0. Going to the frog, we lop off another 0. And when we get to the eagle, that eagle is only getting 30 kilocalories of energy. That's why these organisms near the top have to eat so much, because they get only a few calories from everything that they eat. All right, we're going to come back to that in a minute. But the second example of ecological pyramids is a pyramid of biomass. Biomass is a total amount of living tissue within a given trophic level. And this can vary quite a bit, because each trophic level and the amount of biomass it can support is determined in part by the amount of energy available. Some areas may have more energy available than others, and so the amount of biomass or living tissue that's going to be found in an area is going to vary greatly depending upon the ecosystem that we're looking at. And so a pyramid of biomass illustrates the relative amount of organic matter at each trophic level. Remember, each one of these levels is considered a trophic level, and so ideally, we get about 10% of the amount of biomass that's found in the trophic level beneath where an organism is at. And so typically, you're going to find the greatest amount of biomass at the base of the pyramid, near the bottom, as this picture illustrates here. As you go up, each trophic level is only going to have about 10% of the mass that was found before it. And so biomass is typically measured in kilograms or just in grams, depending upon how large of an area we're working with. Okay, and the last one, probably the easiest one to identify and understand, is a pyramid of numbers. That simply just shows you how many individuals are found within each trophic level. And again, depending upon what ecosystem you're looking at, depending upon what area you're surveying, this can vary greatly depending upon where you are at. And so this example here is showing, well, let's say we had 1,000 green plants near the bottom. And then up above in the next trophic level, we would find 50 snails. Above that, 20 blackbirds. And maybe at the top, we only have one top predator, a hawk. It's simply just showing you how many organisms we can count. And there's a number of different ways in which ecologists can do this. They can tag and release organisms. There's a lot of different methods in which they can actually find the relative number, or in some cases, the exact number of individuals living in an area. Okay, so here's all of these different pyramids just to kind of show you a review of each one. The pyramid of energy shows how much energy is being passed on when one organism eats another. the pyramid of biomass, the living tissue that exists within each trophic level, and the pyramid of numbers. So now what we're going to do is have you turn to page 12 in your packet and find the activity that's called the land to mouth activity. This is an activity that's going to teach you more about the pyramid of energy. And the essential question we want you to think about while you complete this activity is, can you compare the energy between different types of human foods? Ideally, let's say that you were a farmer and you had a field of corn that contains a certain amount of food energy. If cattle were to eat that corn, will they gain some energy? And if so, how much energy will they get from the food in that field? How does the amount of energy in the corn compare with the amount of energy in the cattle? Is it more efficient to feed on the corn or on the beef? In this activity, you will compare the energy content of some familiar human foods. And so here's what we're going to ask you to do. In this activity, you're going to see this huge data table, and the data table below lists a bunch of different organisms. And then it shows you, for example, if you were to grow wheat cereal in your field, if you were a farmer, you could obtain about 3,400 kilojoules per square meter of space in your field each year. Okay, what is a kilojoule? In Europe, they use kilojoules on their food labels, much like we use calories on our food labels. It's just a difference in preference of what unit we use. There is a conversion where 1 calorie is equal to 4.2 joules. Different animals need different amounts of energy. Say, for example, an elephant might feed, or it might take 200,000 kilojoules daily to feed it, where a cat would only need about 800 kilojoules. Each organism is different in terms of how much energy that they need, but in this case, we're looking at organisms and how much energy we could get if we were to grow these different items in our field. And so what we want you to do is a couple things. Number one, if we go to the next slide here, we want you in that data table to label the organisms either as a producer or a consumer. So you can just put a P if it's a producer here, or a C if it's a consumer. Next thing we want you to do is organize the data from least energy to the most amount of energy, meaning we want you to rank these food items to see which one can we get the most amount of energy from, or excuse me, which one we can get the least amount of energy, and which one can we get the most amount of energy from. So we're going to use a 1 for the least amount and 14 for the most amount. And so if we go back here, if we look, for example, the one where we're going to get the least amount of energy from is a fish. So we would put a 1 here. The second least amount of energy we would get would be from growing beef on our farm. So we put a 2. If there's any numbers that are the same, you rank them the same. So I'm going to give you a hint here. You're going to have 2 number 3s and 2 number 6s. Okay, you're going to go 1 through 14. Then you're going to use that information to make a bar graph. You're going to compare the relative amount of energy from each organism. And so in your graph, on the next page in your packet, you're going to make a key on your graph, and you're going to use one color to represent the producers, another color for the consumers. And on your graph, on the x-axis, you're going to put all of the different names of the organisms in which you could grow. And on the y-axis, you're going to show how much energy you could get from growing those different food items. And so here's what your graph should look like. You're going to have a title up here at the top. These are going to be the organisms that would give you the least amount of energy, where you'd have the greatest amount of energy coming from. And then you're going to list them in order. And then over here on the y-axis, you're going to put how much energy you can get from each one and make sure you use the right units. And then you're going to color in your bar graph, with one color being for consumers and the other for producers. And once your bar graph is done, you'll be able to use that information to answer the questions that follow. This is going to take a little bit of time, but you guys can do it. Good luck. And if you have any questions, I'll be back hopefully tomorrow to help you. Thanks, you guys.